everyone, welcome back to my YouTube channel. We are learning database management system in this video series, and today we are going to discuss unit 5 of DBMS, which is query processing and optimization. इसके पहले के 4 यूनिट के वीडियोस अगर आपने नहीं देखे हैं तो उसको देख लेना, so you will be able to connect the dots very easily. The topics which we will be covering in this video are the steps in query processing, measures of query cost, selection operation, evaluation of expressions, query optimization, transformational of relational expressions, and sorting and join. Let's get started with our first topic, which is steps in query processing. पहली बात, query processing होता क्या है? जब भी आपको डेटाबेस में से अगर कोई आउटपुट चाहिए, so first you will give an input, which means आपको कोई डेटा फेच करना है. फॉर एग्जाम्पल अपना रिजल्ट चेक करना है, so maybe आप वेबसाइट पे रोल नंबर डालोगे to fetch the output, which is nothing but result. So ये जो क्वेरी आपने प्रोसेस की वो गई डेटाबेस में और आपको एक आउटपुट जनरेट करके दिया. इस बीच में क्या स्टेप्स इन्वॉल्व होती हैं इन डेटाबेस, दैट वी आर गोइंग टू अंडरस्टैंड टुडे. So majorly there are 3 steps in query processing. The first step is parser and translator. Second step is usually optimizing. So optimizer, and third step is execution. अब इसको थोड़ा और further divide करके समझते हैं through this diagram. Now imagine you have put a query as an input in the database. अब ये होगी high level language में. High level language मतलब SQL में. ये query जाएगी in the first step, which is parser and translator. Parser will check the syntax of the query and verifies attribute name, relation name. कि क्या वो मैच हो रहा है हमारे टेबल एंड एट्रीब्यूट नेम के साथ. Translator will translate the query into its relational algebraic form. Now it is very important that high level language से वो उसको algebraic expression form में convert करे. Algebraic expression format वही है जो हमने सीखा था, select operator, project operator, all of that. Then उस expression में से next step में वो जाएगा optimizing. अब एक query के 2 से 3 या multiple algebraic expression बन सकते हैं. ऑप्टिमाइजर एक बेस्ट अल्जेब्रिक एक्सप्रेशन चूज करता है ऑन द बेसिस ऑफ लो कॉस्ट. लो कॉस्ट मतलब लो टाइम, कम टाइम में कौन सी क्वेरी जनरेट हो सकती है. इट विल चूज दैट एंड उसका एक वो एग्जीक्यूशन प्लान बनाता है. ये एग्जीक्यूशन प्लान जाता है डेटाबेस कैटलॉग में. डेटाबेस कैटलॉग से वो मेटा डेटा फेच करता है, द डेटा अबाउट द डेटा विच वी हैव स्टडीड इन यूनिट 1. ये मेटा डेटा की इंफॉर्मेशन से देन वो जाता है इवैल्यूएशन इंजन, which will evaluate the data from the database and fetch the data and generate the query output again. It will execute the query evaluation plan and returns the output. So इस तरह से ये loop चलती जाती है. So I repeat again, the first step will be checking the syntax and translating it into the relational algebraic expression, which is the low level format. Then it will optimize the best algebraic expression and then it will execute according to that execution plan. Now since we discussed query cost, let's understand what are the measures of query cost and what is query cost. So cost is generally measured as the total time required to execute a statement or a query. पूरा time कितना लग रहा है, on the basis of that the cost is decided. The factors that contribute to the time cost are the disk access, the time to process a data request and retrieve the required data from the storage device, CPU time to execute a query, नेटवर्क कम्युनिकेशन कॉस्ट. ये सारी कंडीशंस मिला के एक टोटल टाइम जनरेट होता है, विच इज नथिंग बट द क्वेरी कॉस्ट. डिस्क एक्सेस इज द प्रीडोमिनेंट विच इज द मेजर कॉस्ट सिंस द डिस्क एक्सेस इज स्लो एज कंपेयर्ड टू इन मेमोरी ऑपरेशन. Cost to write a block is greater than the cost to read a block because data is read back after being written to ensure that the write was successful. इसका मतलब क्या है कि किसी भी क्वेरी को लिखने में ज़्यादा टाइम लगता है देन रीड करने से, बिकॉज लिखने के बाद आपको फिर से एक बार उसको रीड भी करना पड़ता है. So write block usually has a more cost. Now let's understand the selection operation over here. Selection operator हमने already operators में पढ़ा था. If you remember, it selects the tuple from the relation and satisfy a given condition. इसमें conditions के लिए हम ये operators use करते हैं. इसकी notation is a sigma. एक बार फिर से रिवाइज कर लेते हैं कि जैसे रोल नंबर, नेम, ब्रांच, एसबीआई है, वी वांट टू डिस्प्ले ऑल द स्टूडेंट्स बिलोंग्स टू सीई ब्रांच, तो हम सिग्मा लिखेंगे. ब्रांच इक्वल सी कंडीशन लिखेंगे एंड द नेम ऑफ द रिलेशन, द नेम ऑफ द टेबल, स्टूडेंट लिखेंगे, एंड दिस विल जनरेट द फॉलोइंग आउटपुट. Now let's understand the search algorithm for selection operator. There are two search algorithms, one is linear search and binary search. So one by one दोनों search को समझते हैं. Linear search क्या करता है? It scans each blocks and test all record to see whether they satisfy the selection condition or not. For an example, एक array है समझ लो. In this we have record number 2, 1, 3, 5, 6, 8, 2. सो लीनियर सर्च में क्या होगा, अगर मुझे फाइंड आउट करना है नंबर 6, सो वन बाय वन वो पहले 2 के पास जाएगा, चेक करेगा इज 2 equals to 6, नो, देन इट विल गो टू द नेक्स्ट वन and check is 1 equals to 6, no it's not, then it will go to the next one, it will check 3 equals to 6 or not. ऐसे वो जाता रहेगा जब तक उसको एलिमेंट मिल नहीं जाता to satisfy the selection condition. So the cost of linear search worst case is equals to BR. BR denotes the number of blocks containing records from relation R. कितने blocks उसको लगे to reach that relation R. If the selection condition is there on the primary key attribute, then system can stop searching if the required record is found. अगर primary attribute पे है तो वो तो primary attribute हमेशा 0 index पे ही होता है, तो हमें easily मिल जाएगा. If the selection is on non-primary attribute, then multiple block may contain required records and the cost of scanning such blocks need to be added to the cost estimate. जितने blocks वो आगे जाता जाएगा उतना उसका cost add होता जाएगा. So linear search can be applied regardless of the selection condition or ordering of the records in the file. This algorithm is slower than the binary search algorithm. क्यों slower है? Because ये one by one each record check कर रहा है and ये random records भी check कर सकता है. ये ज़रूरी नहीं है कि सारे records it has to be in a sequence. That is not necessary in this. However, still it is slower because it is checking one by one each block. अब binary search में क्या होता है? This algorithm is used if selection is in equality comparison on the primary key attribute. File relation is ordered sorted on the primary key attribute. इसका मतलब है एक array है which has to be in a sequence. इसका sequence में होनी चाहिए 1, 2, 3, 4, 5, 6, 8. Even if one of the element is missing, it's fine, but it has to be in a sequence. It can be either ascending order या तो descending order में होना चाहिए. Cost of a binary search is log 2 of BR. BR again denotes the number of blocks containing records from relation R, and this algorithm is faster than the linear search algorithm. अब ये faster क्यों होता है? ये पहले इसका mid निकाल लेता है. जैसे कि अगर मुझे 6 find out करना है, ये 0 index है, so 0, 1, 2, 3, 4, 5 and ये 6 index हुआ. So what it will do, हम इसको लोअर बाउंड कहेंगे एंड इसको अपर बाउंड कहेंगे. सो मिडल फाइंड आउट करने के लिए यूजुअली लोअर बाउंड प्लस अपर बाउंड डिवाइडेड बाय 2 होता है. सो 0 प्लस 6 डिवाइड बाय 2 अगर हम करेंगे, सो दैट इज 6 डिवाइडेड बाय 2, 3 हमें मिडल पॉइंट मिल जाएगा. सो अब हमें पता है कि 6 जो है वो 3 से ग्रेटर है, सो लेफ्ट साइड की लिस्ट वो चेक करेगा ही नहीं एंड वो डिलीट कर देगा. नाउ इट विल चेक दिस साइड ऑफ द लिस्ट. अगेन इसमें भी लोअर बाउंड अपर बाउंड को डिवाइड करके मिड फाइंड आउट करेगा एंड मिड फाइंड आउट करने पे उसको 5 मिलेगा. अगेन वो इस वाली लिस्ट को एलिमिनेट कर देगा एंड फर्स्ट वाली एलिमेंट को चेक करेगा एंड दैट इज 6 इक्वल्स टू 6. कंडीशन सेटिस्फाई हो जाएगी एंड दैट्स व्हाई दिस विल बी मच फास्टर, क्योंकि ये वन बाय वन ईच ब्लॉक को चेक नहीं कर रहा है. रैदर लोअर एंड अपर बाउंड को लेके मिड फाइंड आउट करते हैं हम, और मिडल से हम चेक कर लेते हैं इज इट ग्रेटर और लेसर. अगर ग्रेटर है तो लेफ्ट साइड की एलिमेंट को हम निकाल देंगे, और अगर लेस देन है तो राइट साइड के एलिमेंट्स को हम डिलीट कर देंगे एंड देन अगेन उसका मिड फाइंड आउट करके चेक करेंगे. Now evaluation of expressions. Expression may contain more than one operation. Solving expression will be difficult if it contains more than one operation. So if you see this expression, इसमें हमारे पास 3 टाइप के different operations है. To evaluate such expression, we need to evaluate each operations one by one in appropriate order. 2 methods for evaluating an expression carrying multiple operations are materialization and pipelining. इसमें bottom to top approach use किया गया है. First we have solved this, then this condition and this project operator as the last. अब हम पहले दोनों तरीके देख लेते हैं, materialization and pipelining. So materialization evaluates the expression tree of the relational algebra operation from the bottom and performs the innermost or leaf level operations first. Bottom से शुरू होगा and innermost expression first solve होगा. The intermediate result of each operation is materialized, which means stored in the temporary relation and becomes input for subsequent next operation. The cost of materialization is the sum of the individual operation, जो individual operation उसका sum plus the cost of writing the intermediate results to the disk. And the problem with materialization is that it creates a lot of temporary relation. It performs a lot of IO operations. For an example, यहाँ पे पहले इस operation को वो solve करेगा, उसके बाद उसका रिजल्ट स्टोर करेगा एंड देन अगेन इस ऑपरेशन को सॉल्व करेगा, देन इन दोनों का रिजल्ट वो स्टोर करेगा एंड देन इस ऑपरेशन को सॉल्व करेगा एंड देन फाइनल रिजल्ट जनरेट करेगा. इसलिए इट क्रिएट्स लॉट ऑफ टेम्पररी रिलेशन एंड दैट विल रिक्वायर लॉट ऑफ स्पेस ऑल्सो एंड लॉट ऑफ टाइम एज वेल. नाउ लेट्स अंडरस्टैंड पाइपलाइनिंग. In pipelining, operations form a queue and results are passed from one operation to another as they are calculated. To reduce the number of intermediary temporary relation, we pass the result of one operation to the next operation in the pipelines. Combining operations into a pipeline eliminates the cost of reading and writing temporary relation. ये कहीं भी temporary relation में store नहीं कर रहा है उसका answer, directly वो pass on कर रहा है to the next relation. Pipelines can be executed in two ways. Demand driven and producer driven. Demand driven का मतलब है system makes repeated requests for tuples from the operation at the top of the pipeline से वो request करता जाएगा. In the producer driven, operations do not wait for the request to produce tuples but generate the tuples eagerly. One by one वो खुद ही next tuples पे जाता जाएगा. So these are two types of pipelines driven operations. So to sum it up, the pipelining, it will execute this query first. The result will get passed on to the next query in the pipeline and this will get operated first and then again the result will get passed on to the next query in a pipeline. So इस method में कहीं पे भी query temporary relation या temporary memory में store नहीं हो रही है, so reading and writing का time again gets decreased. So that's why pipelining is the better method over a materialization. Now let's go to the next concept, which is query optimization. इसका मतलब it is a process of selecting the most efficient query evaluation plan from the available possible plans. मतलब अगर एक query से 2 से 3 algebraic expressions generate हुए हैं, the process of selecting the best one out of it will be a process of query optimization. Let's take an example over here. We want to display the name of the customers जिनका balance is less than 2,500. There are two plans over here. So the difference in both the queries is the plan of evaluating that query. Both the queries have a different evaluation plan over here. This record gives the 6 records and this gives the 8 records. What is the better plan over here? Because we solve the condition first and then the join operation. Over here we are doing the join operation first and then the condition. So this becomes my efficient plan because this gives me data in a less amount of time and the accurate data. There are multiple approaches to query optimization. The first one would be exhaustive search optimization. It generates all possible query plans and then the best plan is selected. It provides the best solution, that we generate all the plans and select the best one out of it. Heuristic based optimization. Heuristic based optimization, user rule based optimization approaches for query optimization. It performs select and project operation before the join operation like we did in the last one. This is done by moving the select and project operations down the query tree. This reduces the number of tuples available for join. Avoid the cross product operation because they result in very large size intermediate tables. हमें पता है cross product operation से generate a lot of query tables. This algorithm do not necessarily produce the best query plan, but it is the efficient one. Now let's understand the next topic, which is transformation of relational expressions. Two relational algebra expressions are said to be equivalent if the two expressions generate the same set of tuples. Example would be customer table is there and account table is there. In this there are 3 attributes, in this there are 2 attributes, but however the number of tuples in both of them are same. First query is this and the second query is this. If both of them giving me the output result same, then this is said to be equivalent expressions. What is the difference between both of this? Over here, the join operation is getting the priority, and over here, we are giving priority to the select operator first. But both results in the same output. So it means both the queries are equivalent to each other. Combined selection operation can be divided into sequence of individual selections. This transformation is called as cascade of select operator. Understand this by an example. There is a customer table over here with a customer ID, account number, name, balance as an attributes. There are two queries over here. Look at the differences over here. We select the account number which is less than 3 and balance less than 2000 of the customer table. The second query also says the same thing, that select account number which is less than 3. Instead of and, we have put this in a separate bracket with select operator, balance less than 2000 of the customer table. So which is the better way? This is the better way, as we have divided individual select operations one by one, and this transformation is called as cascade. However, both are going to generate the same output. So if you look at over here, the first query and the second query of the expression, and the first query and the second query over here are inside the bracket. So which is the better way? This is the better way by using the AND operator. Selection operations are commutative. Let's understand this by an example. It's the same table, however different queries over here. That select account number which is less than 3 in the bracket. The second query which we saw in the last slide, select balance less than 2000 from the customer table. If I compare that with another query, then I will definitely select this one. Over here, if you see balance less than 2000, and in the bracket I have put the account number less than 3. So this is my primary key attribute that has to be outside. So that will require a less amount of time for me to execute that query. We can say that this expression is more commutative over here. Over here, if we see project operator with the name, project operator with the account number, name and customer, not required. We can directly do that. Project operation name from the customer. Both are going to generate the same output. Selection operation can be joined with Cartesian product and theta join. Customer table and there is an account table. If I select the account number less than 3 and customer joined with the account table, or customer table joined with the account number less than 3 with the select operator condition from the account, both the ways are going to generate the same result. The operations are also commutative. We can understand by this example that account natural join with the account number less than 3 from the customer, or if this way, if I use customer natural join with select operator account number less than 3 from the account table. Again, this will also give me the same result. So we can say that natural join operations are associative. Why? Because the order of the operation does not really affect the output of the expression. The result of this will be equal to the result of this. Selection operation distribute over a theta join operation under the following condition, that when all the attributes in the selection condition theta 0 involves only the attributes of one of the expressions, says E1 being joined, is also equals that theta 0 can belong to E1 and join with theta E2 also. So when the selection condition theta 1 involves only the attributes of E1 and theta 2 involves only the attributes of E2, which means the expression 2, in this case we can say that theta 1 and theta 2 with expression 1 and theta expression 2 can be joined, and this is exactly equals to select operator with theta 1 expression 1 joined with theta, and over here we can put theta 2 with the expression 2. This will be more easily understandable with an example. Set operations union and intersections are commutative. Now the set operations like union and intersection are commutative because the order of any of them does not really change the result. If we see over here, customer union employee or employee union customer will give me the same result. In the intersection also same thing, customer intersecting with employee table or employee table intersecting with customer will produce again the same output. However, if we do the same thing with the third operation, which is the difference, the minus operation, in that the set difference is not commutative. Set operations union and intersection are also associative. If we can see customer union with employee table and that entire thing union with the student table will give the same result exactly if we do that customer union employee union student. So this means it also says the order in which if I group the operation does not really change my final result. Over here also, if I group this operation first and then this operation, or if I do the vice versa, customer intersecting first and then employee intersecting with student, it will not change my result. That will be same. Selection operation distributes over union and intersection and minus. Selection operation distributes over union, intersection and minus. So I have given over here 3 summarizing statement. You can take a look at it or take a screenshot of this also for a better understanding or a quick overview. Let's understand the next topic, which is sorting and joins. What does sorting mean? Any relational operations such as joins can be implemented efficiently if the input relations are first sorted. जो input हम डाल रहे हैं अगर वो पहले से sorted हो, so it could be implemented more efficiently. We can sort a relation by building an index on the relation and then using that index to read the relation in sorted order. Such a process orders the relation only logically rather than physically. Hence, reading of tuples in sorted order may lead to disk access for each record, which can be very expensive. So, it is desirable to order the records physically instead of logically. So, sorting of relation that fit into main memory, standard sorting techniques such as quick sort can be used. Sorting of relations that do not fit into the main memory is called as external sorting. Most commonly used algorithm for this type of sorting would be external sort merge algorithm. So, we are going to understand that. Sorting becomes very important if we want to save the query cost, and it has to be done physically instead of logically. Now, there are several ways through which we can do that. So, let's understand that. So, let's understand external sort merge. I have an initial relation which is unsorted. First, we will divide it into 4 equal parts over here. Each part को फिर मैं sort कर दूंगी यहाँ पे. Each part is sorted in an ascending order. Then we will merge them together and sort it again. Then now I have 2 parts. I will merge them again into 1 part and sort it again in an ascending order. And finally, this is my sorted output. How does the external sort merge algorithm works? That we denote the M as the memory size in pages. We create the sorted runs. Let I be 0 initially because first we will start from the 0 index. Repeatedly do the following till the end of the relation. We read the M blocks of the relation into the memory, sort the in-memory blocks, write the sorted data to run Ri and then increment I. Let the final value of I be N. Now merge the runs, N we merge, whatever run we have done by sorting, we merge them and we assume for now that N is less than M. We use the N blocks of the memory to buffer input runs and 1 block to buffer output. Read the first block of each run into its buffer page. So the exactly same method which we done in the last slide. We repeat, select the first record into the sorted order among all buffer pages. We write the record to the output buffer. If the output buffer is full, we write it to the disk. We delete the record from its input buffer page, and if the buffer page becomes empty, then we read the next block, if any, of the run into the buffer until all input buffer pages are empty. So exactly the operation which we did over here is explained in terms of algorithm which we can use to follow. Now let's see the next one, nested loop join, which is also called as sum. Assuming the worst case memory availability and the given statistics for the relation for the customer and depositor. So number of record for the customer which we have is 10,000, number of recorder for depositor we have 5,000, number of blocks of customer which we have 400, and the number of blocks for depositor will be 100. So we need to estimate the cost with depositor as outer relation, with customer as also outer relation. Let's see the first scenario with depositor as outer relation. Number of blocks access equals N depositor, which means this, multiplied by B customer, which means this, plus B depositor, which means this. So 5,000 multiplied by 400 plus 100 will give you this as the result. If I do customer as the outer relation, then N customer will come first, get multiplied with the B depositor plus B customer, and and that will give me this as the result. And if I use this method, number of blocks accessed equals B depositor plus B customer, which means 100 plus 400, that will give me 500. So there are several different algorithms which we can use to implement joins. Nested loop join, block nested loop join, index nested loop join, sort merge join, hash join. So the cost of computing for all joins, R is outer and S is inner relation of the join. For each join, we can see the worst case and the best case, both. Certain joins, we can only see the worst case. So the number of records for R we have represented over here, number of records for S represented by NS, number of blocks for R, BR, and number of blocks for S will be BS. You can take a screenshot of this and you can use it for solving other questions. These are certain questions which are most asked in Unit 5, so you can solve them and write proper answers. If you have any doubts or any questions, you can definitely mention in the comment section. अगर वीडियो आपको समझ आया है, then do give a like and subscribe my channel for the next video. I will see you in Unit 6. Happy learning. Bye-bye. Thank you.